Up until now, all the data we've used has been generated by Rhino or Grasshopper. So what if you have a data set that you generated in another application or through another process that you want to drive the definition? We do have a few options, and I'll show you one here, and we can do it with params input read file. Perhaps the data is in a text file or a CSV file where we could use a read file to read that data in. And this component essentially takes a file path to where the file is actually saved and then gives you back the data. And by default, it does it per line. Here, for example, I have this point cloud file that has a point per line. And we have x, comma, y, comma, z. So it's a pretty simple file format. What I'm going to do is I'm actually going to drag the file, just like we can drag images, I'm going to drag the point cloud file into the definition, and you'll see that it just is the same file reader component, but this time it has the file path. What I'll do now is see what is happening with the data. It is being read in here. I do get the same data that I saw in Notepad, but we don't see the points because Grasshopper isn't going to assume that these are points. Because the data is so simple, we could actually just go to params, geometry, and point. We don't need to go in there and parse it or do anything. There we go. It's simple enough that it can eventually just generate points out of it. Otherwise, would have to go in there and split the data by the commas and eventually reconstruct the points. But in this case, it's just fine. We don't need to do that. Now, in the case of something that's a little bit more complex, we will need to parse it. I have here another file that contains the Barcelona weather for 2012, things like the average temperature, the high and low temperatures, etc. And I got this data from Weather Underground. Weather Underground allows you to eventually query a weather station, and here I can use a custom query to do from, for example, January 1st through December 31st. And that's what I did exactly here. And we have the data for 2012. Let's go ahead and drag that into our definition. And let me turn this off here. In this case, the data is a bit more complex. We don't just have points, we actually need to decide first what are we going to do with this. Let's say we wanted to graph the temperatures. The first thing I'm going to do is I'm going to look at how I have the data here. And I notice that I have the first line as a header. So it's telling me all of the data that I have in here. Make this big enough so that we can see what we have. So that first line seems to be comma separated, and it's telling us what each of the values mean. After that, we have all of the entries of the data with the date, eventually the max temperature, mean temperature, minimum temperature, and so on and so forth. What I'd like to do is I'd like to first separate out that first line from the rest of the data. It's going to also be useful to understand what I have in my numbers. So I'm going to keep it around. I'll first go to sets, list, and list item, and I'll just isolate that first line. It didn't separate it from the original, but I've isolated to show you how we're going to actually split out and parse the data. Because this is just now one line of text, we know that it has the comma, so we can use that as the delimiter. Let's go to sets, text, split text. We'll split this text up based on the comma separator. Plug in our text to T, and in C, I need to plug in a comma. I'll double click on the canvas, quotation, and just add a comma. Let me make that a little bit bigger so you can see what that is. Zoom in here. So this panel literally just contains comma. We'll plug that into C. Now let's see the result of that. Now instead of just one line of text, I actually have all of the values in the list. What this is going to be helpful for is that now we can actually see in the data where the values will be. So for example, if I just want to deal with maximum humidity, I know that it's at index 7 after I split the data. So this is our legend. Now we do actually have to move this first line off of our data. Let me just bring down another panel so we can see what we're doing. I want to shift this first line off of the data. I'm going to go to sets, list, and shift list. I'm going to shift, and I don't want it to wrap back around, so I'm going to go to params, input, and Boolean toggle, set that to false. So now here I only have my numeric data. We also need to split this, so I'm going to copy my split component, Control-C, Control-V. I'm going to leave the comma there, plug in the list into T. Let's see what we get. Now we have a data tree. So for each day, we have a little branch of data that is giving us this information. Let's put this next to the legend to see if it makes sense. So here I'm just looking at the first day of the year, January 1st, and I'm going to put these side by side. So here I have the date, I have the max temperature, mean temperature, minimum temperature, and this is in degrees Celsius. We also have sea level pressure, all sorts of different data that could be interesting. Now let's say that we just want to show the temperatures. Actually, keep this here. I want to show the max, mean, and min temperatures. let me isolate those. I'm going to go to Sets, List, List Item. Here, I'm going to pick out, for example, the mean temperature. In a panel, I'll put the index of that, which is index 2. If I'm not mistaken, mean temperature, index 2. So I'll plug my data tree into L and the index into I. What I've done now is I've actually retrieved all of the average temperatures for the whole year. Actually, what I could do to graph that, I could go to Display, Graphs, and Quick Graph. Plug that there. Because it's in a data tree, each branch is a different day of the year, the quick graph isn't going to show us much, so we actually should right-click on I here and flatten. There we go. Now we can see throughout the year the mean temperature. Let's say we also wanted to graph the humidity. Humidity, if I look back at the legend, we have eventually the mean humidity. Let's use here mean humidity, which is index 8. Before I go on, I'm going to actually make a label. I'm going to select this, Control G, and I'll just put a label. This is average temperature. And this is in degrees Celsius, so I should probably also indicate that. Let me copy this, and the humidity is index 8. Here I am going to right click on the group and say average humidity. This is just a quick way to bring in data from an external source. You know, the data is pretty simple. Each line represents some kind of meaningful thing. In this case, each line represents a different day of the year, and we get all of these different pieces of information for that particular day. Now, when we split it up, we get a data tree. So we have a branch per day, and then we can isolate the values and start to graph them with the display graphs quick graph.